Okay, welcome back everyone. Let's talk about linear programming today. So up to this point, over the past few days, we've been graphing inequalities. I've been referring to them as constraints. And then we were plugging them into this f of x, y function. Okay, well, today we're going to figure out where this all comes, why it's all tied together. So we use this when we have constraints on variables, x's and y's, and, 2x plus 3y must be less than or equal to 4, for an example. Okay, so we have these constraints and we're going to graph them. The function of these variables, when we're asked to minimize or maximize this function, again, we'll talk about where the function is created from. It could be something like profit or revenue for a company or minimizing labor costs, whatever the case may be. Whatever your goal is, you may want to minimize it or maximize it. And those were those f of x, y functions we came up with. Okay, for example, 2x plus 3y. Right? For homework the other night, we were given that. Today we're going to create that. In the dictionary, it's, what does it say here? We have a method of solving practical problems, okay, where we're trying to allocate certain resources. We only have so much labor. We only have so much time in a day. All these things are constraints, okay? I'll leave this up here if you want to just read that over, okay? Here's just a quick little chart. Let's see what this is all about. So, for example, what we have here is similar to what we were doing for homework. We were graphing a whole bunch of inequalities, and then I told you we're going to focus on the vertices of that polygonal convex set. Well, here, in a real-life situation, say we're creating chairs, or producing chairs and tables, okay? And then from there, we have certain things that are limiting us. The finishing, it may take a certain time frame, 4 hours to do the tables, and it might be 1 hour to do the chairs. Well, when I add up that time frame, say I only have 400 hours worth of labor available to me. Well, that has to be less than that or else I can't do it. Profit. Okay, these are all different things we need to consider. Assembly. Say it took time frame. Say it takes an hour to assemble a chair, but it takes an hour also to assemble a table. But again, that workforce, we only have 200 hours of labor. So it gives us a constraint. We're only working within a certain limit. And then what we're going to do is we're going to figure out those vertices, and we're going to plug them into our maximizing or minimizing function, this f of x, y over here. Let's look at some of the different types of solutions we get out of these. All right, these graphs may look familiar from one of my earlier lessons, but they get the same idea across. So if we have something called an infeasible solution region, this right here is an example of an infeasible. Let me write that down for you. Okay, this would be an infeasible solution region. Okay, region if you want, because remember with inequalities we have regions, not just an xy point. Well, the reason why it's infeasible is there's nothing that would work for both inequalities. I have an inequality where it's greater than this line. I have an inequality where it's less than this line. There is no xy point in here that would also fall in here. So there's no xy point associated to both inequalities. It's infeasible. There's no solution region. Next, we have an unbounded. Okay, well, both of these, this one and this one, they're both examples of unbounded. Okay, I don't have something cutting it off. I don't have it. It just keeps going forever this way. Remember, these lines keep getting bigger and bigger this way, so this region just keeps getting bigger and bigger. So there's no bound. It's unbounded. There's nothing to bound it. Okay, so I'll just write unbounded for this one. Okay, that's an unbounded. And that's the same thing with this one right here too. Okay, they're both unbounded. Another one we have is what we're primarily going to be concerned with today. Okay, and that's something like this. Whoops, let me just bring this one front. Oh. Okay. So this one right here. This is called an alternate optimal solution. You're going to see that wording in your notes or in your homework, so let me just get it down here. Alternate optimal solution. this gives us a region where we can actually focus on. Okay, I know that the XY values that are associated with all these inequalities fall in this triangle. And like we talked about in class, the min and max points are only going to fall somewhere on those vertices. So we just have to focus on evaluating these 3 XY points. Okay? All right, at this point, if you don't feel like copying all this, I have a handout called 2-6 Linear Programming Handout in that Unit 2 folder in Edmodo. Either call it up on your phone or your iPad or whatever you have, or print it out so you have a copy of it. All right, so you may want to pause right now and do that. Or you can continue and copy it. It's up to you. But it's a word problem, so let's talk about this. We're going to break this down. Okay? This handout, like I said, is available in Unit 2 folder. So we have a farmer. All right? Here's a real-life situation. A farmer has 10 acres, and on that 10 acres, we're going to plant wheat and rye. Okay. Well, he has a few constraints. He must plant at least 7 acres for whatever reason. He's paying taxes on farmland, and they have to have at least 7 out of the 10 acres be planted. But he also has another constraint here. He only has $1,200 to spend on each acre of wheat. Oh, I'm sorry. He only has $1,200 to spend overall, and each acre of wheat is going to cost $200 to plant. So each acre. So if there were 2 acres, that would be $400, etc. And each acre of rye costs $100 to plant. So if he plants 3 acres of that, it would cost $300. So we got to find the best compromise between these two with this constraint. We only have $1,200 to work with. The farmer must also get the planting done in 12 hours. Well, that's obvious because once it gets dark, it's hard to farm. So he has a time constraint. And in this time frame, it takes him 1 hour to plant 1 acre of wheat. It takes twice as long. It takes 2 hours to plant 1 acre of rye. The profit on is $500 for each acre of wheat and $300 for each acre of rye. Now, before I continue, you might say, okay, well then let's plant all wheat because you make more money. Yeah, but it also costs more. It costs more to do the wheat, and there are other things you got to consider than just how much am I going to make. How much do you have to spend? That's the key. So anyway, the overall question is how many acres of each should we plant to maximize profits? That right there is what we're trying to do. We want to maximize the profits. Whatever you're asked to maximize and minimize is going to be your f of x, y function. Okay, we'll get to that in a minute, but that's what we're going to do. So now the question here. How many acres of wheat and how many acres of rye should be planted? That's what we're asked here. How many of each? Well, if we call one of them x and one of them y, when we solve for x and y, we have our answer. So why don't we call x the number of acres of what was first? Wheat. Okay, so we'll call x wheat. And we'll call y the number of acres of rye. I'll just do the number of acres of rye. Okay? So again, when we solve for x and y, we have what they're asking for. Oops. The objective. The objective is to maximize our profits. That is what the f of xy function is going to be, whatever they're asking you to maximize or minimize. Okay. Each acre of wheat, where am I? Right here. Each acre of wheat brings in 500. Now again, I'm talking about profit, so I got to look at the profit values. Let me just erase that here. Okay. So we're right here now. The profit, we have 500 for each acre of wheat and 300 for each acre of rye. So how could I write that? Oh, I have it down here also. Well, we make $500 for every acre of wheat, and we make $300 for every acre of rye. So if I multiply those and add that up, we'll get the overall profit. Right there is your f of xy function. Okay? That's how you figure that one out. Let's move on. Okay, so we've defined our unknowns and express our we've defined our unknowns. We know the x and y. We've expressed our objective. We're trying to maximize our profits, and there's our function. Everything else in the word problem are constraints. Okay? So from that word problem, I broke them down here. We were talking about acreage. Okay, we must plant at least 7 acres and no more than 10 acres. All right, well, think about this. If I take the number of acres of wheat plus the number of acres of rye, hold on a second here, that has to be greater than or equal to 7 acres. But I also have this constraint. When I add the number of acres of both, it must also be less than or equal to 10. That's an equal time. Okay? That came straight from the word problem, the time constraint, or the acreage constraint. Now for the cost constraint. Well, for the cost constraint, we only have $1,200 to spend on planting. Okay, so the maximum we can go is $1,200. Anything we do must be less than or equal to that amount. All right, well, it cost us $200 for each acre of wheat, and it costs us $100 for each acre of rye. That value must be less than or equal to $1,200. Okay. The other thing that they mentioned in the word problem was our time constraint. We have to do it in 12 hours. Okay, the sun is only up for so long, and then it goes down. It gets dark. So, how can we talk about that? Well, again, let me just change the color. We got a lot of blue going on. Our time constraint is we must have it done less than or equal to 12 hours. Okay, so whatever we're doing has to be less than or equal to half a day. So it did say that it took 1 hour for each acre of wheat, and it took 2 hours for each acre of rye. So that would be the time frame. That time frame must be less than or equal to 12 hours. Implied constraints. Implied constraints, like I said in class, come up often. Remember what X and Y represent. Oh, I erased it. There was the number of acres of wheat, and then the number of acres of rye. Well, can you plant -4 acres? No, you're either going to be planting some acres or you're going to be planting no acres. You can't plant negative acres. So, back to our implied constraints. That means that whatever X is, the number of acres of wheat, must be greater than or equal to 0. We can't go negative. And the number of acres of rye, same thing. I can't plant negative rye. It's either none or some. Here are our inequalities that we need to graph. All right, so let's see what happens when we start graphing all this stuff. Okay, this is a handout that I had, but we're doing this digitally now. So let me just, for the moment, cover up this stuff right here. All right, so our first acreage constraints. If I graph those inequalities, okay, I'm sure you can solve for y and figure this out, but you would have this line would create this, and it has to be less than that line. And then this constraint needs to be greater than or equal to that line. Okay, and again, I just solve for y and then graph my lines. Y equals mx plus b. All right, so that leaves us with this possible region for our solution. But we must overlay with that with our next constraint, which we identified as our cost constraint. Okay? So now think about this. So we had this region in here all shaded, but then when I overlaid this one, it was this line right here, and it needed to be less than that line. So now we're only left with this region in between those two parallel lines. That was our cost constraint. Okay, now on top of that, we also had an additional constraint that we must consider. Well, yeah, let me get rid of this now. Here, compare these two. So now, we also had this time constraint. This was our time constraint. If I were to graph that line, which is the line, it kind of creates this line right here, okay, where the arrow is pointing. Well, if it must be less than that line as well, then it gets rid of all this region up here, and what we're left with is this little tiny triangle of possible solutions. That's our optimal solution region, okay? But like we said in class, we really only have to focus on the vertices. That's where the minimum or maximum points are going to fall, okay? So our job now is to find out what this A, B, and C are. The rest of this problem is just like we've been doing for homework. Okay? So now I can get rid of this. So let me just get rid of that. Okay. When you solve for these, again, how did I do it? Well, just use your calculator, okay? Plug in one line and the other line and find the point of intersection. Plug in this line and plug in that line and find the point of intersection. Do the same thing to figure out your point A, okay? And when you do that, if you do it correctly, you should get these 3 vertices, okay? So right here are the vertices you should get when you find the points of intersection. Back to our profit function. Well, this is the profit function right there. Let me make that bigger. We need to evaluate these vertices. So let's see what happens. Let's make this pretty purple. So the first one would be 500 times 5, our x is 5. 300 times 2, our y is 2. And that's going to give us a value. We'll figure that out in a second. This one is going to be 500 times our x value, which is 4. And 300 times our y value, which is also 4. Okay. And then you do the same thing with this xy point. I have 500 times 2 and 300 times 5. Now let's figure this out. If you do the math, this first one is going to come out to be, hang on one second, $3,100. Again, this represents our profit. If we did this combination, if we grew 5 acres of wheat and 2 acres of rye, we would wind up with $3,100 in profit. If we planted 4 acres of wheat and 4 acres of rye, that would give us a profit of $3,200. And if we did 2 acres of wheat and 5 acres of rye, that would give us a profit of $2,500. Since we're trying to maximize our profit, well, what's the biggest number you see? That is your maximum value. You can possibly make $3,200 in profit if you planted that combination right there, 4 acres of each. This is real life. This is how it's done. I mean, you got a big corporation with all these variables. I have so many people in my labor force, so many hours they can work each week. How much material do I have? What can the machines I have handle? These are all constraints, and this is what people do to figure out how to maximize their profit. All right, so if any of that was unclear, please just rewind it, go back a few minutes and watch it again. I think once you see it a couple times, it will truly make sense. When you're doing your homework, let's try to simplify it for you. These are the things you should follow. If you could do this, you're on the right track. So first and foremost, we need to identify our variables, just like we did before. What's our x and y? What are they asking us to solve for? That is your x and y. So when you solve for them, you have your answer. Then what you need to do is pick out the constraints. Write them as a system of inequalities. Okay, you're going to get them out of the word problem, just like we did with the farm example. After that, what did we do? Well, we figured out it doesn't really matter which one you do first or second, but you do need to also figure out, what am I optimizing? What am I minimizing or maximizing? Just so you know, optimizing is either minimizing it or maximizing it. You're trying to optimize whatever you're looking for. And that right there, let me just write that. This is going to be your f of xy function. Okay? These are all your inequalities, if you will. Next, graph the system and find the vertices of your polygon. All right, we've done that. In the example we just did, our vertices were A, B, and C. Okay? Next, we evaluate those vertices in the function. We then plug in those f of xy values into our f of xy function, and we figure out the smallest and biggest value. What are we looking for? Well, it'll tell you. They want you to maximize something or they want you to minimize something, and you pick the smallest or the biggest accordingly. And so there you have it. Okay, let's look, see what we're going to be working on tomorrow in class. Don't forget this outline is in Unit 2 Edmodo folder. Okay, so we just did, let me just change this. We just did this day 1 of linear programming. We will be working on page 95 in class tomorrow. For all of you out there who keep asking me, what was the homework assignment? What was the homework assignment? Well, one of two things. Either print out this outline so you have it, or right now in your notes, just write page 95, 12, 14, and 15. Just write that down, and then when you open up your notes, you'll know what it is. See you then.